An MCP server is an adapter of sorts between, on the one side, an MCP host, something like Claude or Cursor, and on the other side, a source of information or processing. In the case of this video, that'll be a robot. The structure of this video will be, first we'll look briefly at the robot, along with an app to control the robot, and then we'll switch to the architecture of this system, that is the MCP server, and how it communicates with the MCP host, as well as how it communicates with the robot. Following that, we'll look at the code, and then how to integrate that code with an MCP host. Again, we'll be looking at Claude and Cursor. However, this is the case. You could use it to integrate with any host. And then we'll do a demo showing the MCP host, that'll be Claude and Cursor, interacting with the robot. So this is the robot that's going to be used. It's a binocular robot. I'll just be using one of the cameras for this, and it's also a differential drive. This is the app. This is available in the App Store. I'll include a link. This can be used to control it, for example, to make it move forward or back or side to side or what have you. So there's also, as I go to in the next section about the architecture, there's YOLO in here, which does a very rapid analysis of the image. Image is captured by the camera, and so I'll go ahead and kick that off here.
I see one person, 2 chairs, 1 dining table, 1 laptop.
So that's going to be used for the robot, the description of the robot's location or the surroundings, as we'll see in just a little bit. This diagram shows the relationship between the MCP host, the MCP server, and the robot. The MCP host, this would be something like Claude or Cursor, has 0 or more MCP clients running. So these MCP clients have a one-to-one relationship with an MCP server. Basically, these are effectively peers. And what the MCP client permits, or that coordinating with the MCP server, is for basically an extension of functionality on the host. In this case, it lets it get a robot name, or describe the robot surroundings, or get the latest image from the robot, or get robot info. That's a prompt. These 3 will end up making calls to the robot. At this point, when you're on your side of the MCP server, you can use whatever you want. You could call a REST endpoint, or you could call over Bluetooth, or you could call directly to a database, or what have you. So that's at this is the point where your code gets involved in providing functionality ultimately for the MCP host. In this case, there are 2 tools, robot name and describe surroundings, and these call a REST endpoint. Each calls a REST endpoint. So one's get robot name, and this is on the robot at this point. So that makes a shell call to host name. You could, of course, do what you want. You could return a hard-coded name, but in the case of this robot, it calls to it makes a shell call. The get robot surroundings makes a standard I/O call to YOLO. So there's running on the robot. There's some object detection. There's a neural net for object detection. YOLO running in Python. And that also, if you heard the robot say what it had seen, that's kicking off something in the shell, namely a play, and that then talks via the hardware. In the case of the resources, the latest image basically just grabs the latest image from one of the cameras, in this case the left camera, and that uses OpenCV. And again, standard I/O. This is basically the control plane, and this is it gets the image, the bulk image, actually via the file system, and that talks to the camera there's also other things going on the robot, like it talks to an Arduino via UART, and that then talks to some motors. So any of these, for example, this could have added something for having something on the MCP server have the robot move by there's a different endpoint that permits movement. So the this is the overview of what the different systems are doing: the host, the server, and the robot. The next thing we're going to look at is the code for the MCP server, and then also a little bit about how this integration takes place. There's a JSON file that's involved in that. So now we'll skip over to the code. So we'll start looking at the code in a moment. This is the robot running. I'll point it more towards me. I've got my phone mirrored on my Mac. So we'll first set up the folder, and then we'll look at the code. So and I'm using UV, which I would highly recommend. We'll add, this is for fast MCP, don't forget the parentheses. And requests. And then we have, it's all set up. This main.py, that's where we'll be putting the code. So I'll switch over. I have this already set up. The easiest way to do this is actually to just take a git pull or a git clone. I'll have the git repo to use in the description. So this you'll need for any fast MCP project. So this is one might say boilerplate. There's like 4 different sections to this file. One is those things, and you can see those annotations that describe the tools, the resource, and the prompt. The prompt, just to address that briefly, this is something that you're basically providing a convenience for the end user, that they can have a prompt. If you have a long and complicated prompt, you might have that here. That would provide some value for the end user. But it's these prompts, they're actually used by the end user. We can see one in either Claude or Cursor. The MCP tools, and this is, I think, the most commonly used, that basically does something and returns something. You can actually pass in values as well. So in this case, the described surroundings will be, and the doc string is important because it's used by the MCP host for inferring when this should be used. So this is describing, or this will return the surroundings that we saw demoed with the robot. Basically, it uses the camera frames, the images that it's capturing, and it runs them through a YOLO, which is a neural net, and then it returns objects that it recognizes. So that's the described surroundings. The robot name just calls the OS host, and the latest image returns the latest image that has been captured from the latest image that's captured from the camera. These are all very similar in that first thing is getting the URL to use, and this is important. If you want to have something where the end user can pass in some information, let's say an API key or a base URL or something along those lines, you'll end up, it'll be described in the mcp.json, and we'll return to this in a minute, but here's those env values here. So when you have these, or once the base URL, and whether it's HTTP or HTTPS, is retrieved from the OS environment, then the URL is created and returned to the calling code. So in this case, it'll get the URL for getting the robot surroundings, in this case, the robot name, and in this case, the camera that it's going to call to get an image. Once this is done, the next step is to, in this case, get a URL body. So this, if we skip down here, it just calls that URL, and it returns, and there's an as binary passed in. So it's either the content if it's binary, or text if it's not. So this is basically the image. This is binary content. Important here for this, which is returning the bytes, is that this will return the binary, and these two are returning strings. In most cases, the tools and resources will probably be returning strings, but in this case, if it's a case where you're returning some binary data, use bytes. The usage of tool versus resources it seems somewhat arbitrary. Tools seem more commonly used. Resources are for things like calling a database, or in this case, images. So that's the sum of it. This is, again, available in GitHub. So if you want to use it as a template, clearly this could be calling, these are calling endpoints. These could be calling out via Bluetooth or what have you. So let's go over to look at how the integration is done with, first we'll start with Cursor because we're in Cursor, and then switch over to Claude. So this is actually, let me go through the process of how to get here. So in Cursor, go to Settings, and then go to Cursor Settings, and then go to Tools and MCP. And I already have this installed, so it'll show if everything's running properly, it'll be 2 tools, 1 prompt, 1 resource. So, and this is indeed enabled. If you're just starting and you don't have anything here, just click New MCP Server to actually go to the same place, which is a config file. So this is a config file, and I have it set up. What you'll have, if you don't have anything set up here, you'll have this, and this is what you will add from here to here. I'm going to include this in the Git repo as well. So you'll have to look at the paths on your system. I have UV set up via Homebrew. Certainly, if you're on Windows, this is going to be different. So look at the path to UV, assuming you're running with UV, and then you also need the path for the main.py, depending upon how you have your path variable set up and that kind of thing. But you may need the entire path. If you're having problems, definitely use the entire path. And these again are the environment variables. So once you add this, you may need to restart. But once all that's done, then you'll be able to use the MCP tool. So if, for example, I type, what is the robot's name? Yeah, EBR3. So that's actually the host name. So that is indeed the robot's name. I'm going to run YOLO.
I see 2 persons, 1 chair, 1 dining table, 4 laptops.
Well, not quite 4 laptops, but that's okay. So we'll go ahead and get this. The next step will be to describe the surroundings. So next up. And this is done on the um, on the robot side. When we get the image, then we can run it on the cursor side. I think this getting image is actually pretty cool. And that's me. So this this as you can see is returning a binary. So this is actually pretty cool. Claude actually does a description of it. So and then the final thing is this is the prompt, and the prompt. So next up we'll do the prompt, and here's the prompt. And that's it. So that shows the two tools, the one prompt and the one resource. We'll skip over to Claude, which I think I have running over here. So Claude, very similar. You go to settings, go to developer, and you go to edit config. And then that'll bring you to a JSON file here, and it's the same. It's you put in, it starts with MCP servers, and you put in iSpot. You may be adding it to a list that's existing, or maybe adding it for the first time. Again, this is going to be in the Git repo, so might want to pull that down. So then we'll go to chat. Okay, that's the right robot name. Great. Can also do things conditionally. So that's good. And now the resources, which are down here. Where are they? Oh, sorry. So we'll grab the latest image. And then Claude describes it. I think this is pretty cool. And it does actually a much better job than YOLO. And finally, the get robot info is not particularly valuable prompt. And that's it for this demo. Again, this is going to be available in Git, particularly this MCP and this code here. I'm going to be making more information, including the source for running the robot, available. If anybody's interested in having like a robot, that robot is a kit, then please let me know. So that's it for today. I'm working on some other. I'm working on using LangGraph to do something agentic with that same robot, and also RAG, again in the context of robotics. So probably have some more videos coming up in a bit. If you have any questions, please feel free to leave them below, and I'll definitely have a look at them.